Unit 2 Chemistry, Chapter 16, Part 2. Now we're looking at writing equations for redox reactions. So, as we said before, each redox reaction has got two half reactions. So we're going to have two half equations. One which is for the oxidation half reaction, one for the reduction. Okay? So for instance, if you have copper, which is losing electrons, so it's oxidation, and is becoming copper 2+. We would write it like this, and we are explicitly writing the electrons here. We could then have those electrons going to something like silver, which is less reactive and would much prefer to be in its pure state, thank you very much. So silver can grab one electron, because it's only got a charge of +1, to become solid silver. Notice here that we have to have a balanced equation. So everything has to be balanced, including the charge. So this has got a 2+ charge, here we've got 2 negative charge, so that gives a charge on this side of 0, which is the same as that side. Okay. If we want an overall redox equation, we always start by writing the two halves separately and then combining them, because that allows for the fact that we've got to lose electrons from one and gain them in the other, so we've got the right number of electrons in each. Okay, so in this case, copper loses 2 electrons. Each silver only gains 1 though, so we need to double this. Okay, and that gives us 2 silver ions and a copper atom. It's going to give us 2 silver atoms and a copper ion. Okay, and that's why we had to do the two half equations, because if we didn't, we might just go 1 to 1 to 1 to 1, which would account for our atoms accurately, but which wouldn't give us the right number of electrons being exchanged. Okay. The electrons have got to cancel out, so they're not in the overall equation. So we did lose 2 electrons, we also gained 2 electrons. That's the same on both sides, so we cancel it out. Now there are some things that cause others to lose electrons. If we cause something else to lose electrons, then it is causing oxidation. So it is an oxidizing agent. Okay? When it causes that, that means that it itself must be reduced. Okay? Because it's causing something else to lose electrons, so it's got to take those electrons from it, because the electrons can't be on their own. So we call it an oxidizing agent or an oxidant. It is the thing that's reduced. A reducing agent or a reductant is the thing which is oxidized. Yeah, I know it's confusing. I didn't make it up. Okay? They're named for what they do to something else. So oxidizing agents cause oxidation. Reducing agents cause reduction. But the opposite thing happens to them. So an oxidizing agent is itself reduced. A reducing agent is itself oxidized. Now sometimes we have nice simple equations like these ones here, in that we've just got one element on either side. Sometimes we have more complex ones. Most commonly that's because we've got hydrogen or oxygen present and we've got some polyatomic ions. Okay, if we have that, and most of the time this is happening in an acidic one, sometimes it happens in a basic solution, but normally it's acidic. The first thing we do, just as normal, is we make sure we have an oxidation and a reduction half reaction. And we balance what we've got there. We then balance any element we've got other than hydrogen and oxygen. Then to balance oxygen, we add water. To balance hydrogen, we add hydrogen ions. And then we balance the charge. So let's look at an example, okay, because it's much easier to see in an example. So we've got permanganate is reduced to make the manganese ions. So we first of all check that my manganese, that's got 1 atom on either side. We're good, we're golden. Now then we look at our oxygen. We've got 4 oxygens here and none there. So this is where we're going to use water to balance oxygen. So we add 4 waters to the right hand side, and we've now got 4 oxygens here and 4 oxygens there. That screws up our hydrogen though, because now we've got 8 hydrogens over here and none here. So we're going to sort that out by adding these 8 hydrogen ions to make sure we've got 8 hydrogens on either side. Now the final thing we've got to do is sort out the charge. Currently, we've got a charge on this side of +7. 8 positives, 1 negative gives us +7. On this side, we've got a charge of +2. To sort this out, we're going to add electrons. Now, electrons are negatively charged. We're going to add electrons, therefore, to the most positive side, so over here. And we want to make the charge equal. We don't want to make the charge 0 on both sides, we want to make it equal on both sides. So we need to add 5 electrons here, and that gives this side now a charge of +2, and this side a charge of +2. Final thing we do, add our states.